Hello everyone, welcome you back for the computer assisted part programming. In the previous classes also we had discussed about the part programming. Now what is the difference between that program and as well as this program? This program, now what we are discussing or what we are learning is with respect to the APT program, which is nothing but automatically programmed tooling. APT is a three-dimensional NC programming system. Now APT is not only a language, it is also a computer program that processes the APT statements to calculate the corresponding cutter position and to generate the machine tool control commands. Now computer assisted part programming. In the computer assisted part programming, which is nothing but APT, the machining instructions are written something like a English statements only. These statements are subsequently translated by the computer into a low-level languages or the low-level machine code that can be interpreted and executed by the machine tool controller. When using one part programming language, the two main tasks of the programmer are the defining the geometry of the workpiece and specifying the tool path of the operation sequence. These are the two essential parameters normally which is required in the case of the APT programming it. The first and foremost is defining the geometry of the work part, and also the tool path and the operation sequence is also most essential. But in the case of the normal part programming, what we used to do it, we are not defining the geometry of the work part. Now computer assisted part programming. There are four basic types of statements are available in the case of the APT languages. The first one is nothing but the geometric statements. The geometric statement is called the definition statements. Here what we are using is nothing but the geometric elements that comprises the part. We indirectly what we can say, the dimensions of the part is specified in the geometric statement. The motion command are used to specify the tool path, which is nothing but how the movement is taking place. Either the tool is moving in the clockwise direction, or it may be in the counterclockwise direction, or it is moving in the backward direction, or it may be in the forward direction. These things it has to be specified in the motion command. The third part is nothing but the post processor statements. The post processor statement controls the machine tool operations. For example, specifying the speed, feed, tolerances, and a circular interpolation and accurate other capability of the machine tools. The fourth one is nothing but the auxiliary statements. The auxiliary statements are the group of miscellaneous statements used to name the part program, insert comments in the program, and to accomplish the similar functions. Now, the statements are constructed of APT vocabulary words, symbols and numbers. All are arranged using a appropriate punctuations. APT vocabulary words consists of 6 or fewer characteristics. Most of the APT statements includes slash as a part of the punctuation. APT vocabulary words that immediately precedes the slash are called as the major words, where those that follows the slash are called as minor words. For example, in the geometric statement, symbol which is equal to geometric type slash descriptive data. Now in the geometric statement, the first what we are discussing is with respect to the point. Point P1 which is equal to point slash 20, 40, 60. The P2 is equal to point slash into OF L1 to L2. The commas are used to separate the word and numerical values in the descriptive database. Now in the first statement, the P1, the points are defined, which is nothing but 20, 40 and 60 is with respect to the x, y, z. But in the second statement, where the point is defined with respect to L1 and as well as L2. L1 and L2 are the lines where it is meeting, which is nothing but the intersection of. INTOF is nothing but the intersection of. Now the line is defined in APT is considered to be a infinite length in both directions. All APT treats a line as a vertical plane that is perpendicular to XY line. L3 is equal to line P3 comma P4. L4 is equal to line P5 parallel to L3. Now here in the geometric statement L3, as we know that the line is defined by the 2 points, which is nothing but P3 and as well as P4. The P3 and P4 it should be defined in the previous statement, and the line joining between the points P3 and P4 is nothing but L3. The L4 is a line which is nothing but a line which is parallel to L3, which is nothing but a P5. Now the circle in an APT circle is considered to be a cylindrical surface that is perpendicular to the XY plane and extends to the infinity in the Z directions. C1 is equal to circle slash center comma P1 radius comma 25, or C2 is equal to circle slash P4 P5 and P6. C1 is the statement in which circle is defined by the center with a point. The center point P1 is defined and the radius of the circle, which is nothing but a 25 mm. C2 is defined by the circle, the point and as well as the radius. Now the plane is in the APT planes extends to identify PL1 is equal to plane slash P1 comma P2 comma P3, or PL2 is equal to plane P2 parallel to PL1. Now the rules for formulating the APT geometric statements. The first one is the coordinate data must be specified in order to the X, Y and as well as Z. Any symbols used in the descriptive data must have been previously defined. A symbol can be used by defining only one geometric element. Only one symbols can be used by defining a given element. In this slide, the component is described. This component dimensions is also described. With respect to that, we are doing the program in the next further sessions. For examples, here in the case of the part geometry, P1, P2, P3, P4 are the points which has been defined with respect to the component. Now, the L1 and L2, L3, L4 are the lines which are the lines with respect to the point P1, P2, P3, P4, P5, P6, P7, P8. And also the circular path which is there in the component, that is also defined by the line the circle C1. The next one is nothing but the motion commands. The motion commands are the commands which gives the movement of the tool. For example, go to P1. This statement consists of two sections separated by a slash. The first section is the basic command that indicates what move the tool should make. The descriptive data following the slash tells the tool where to go, which is nothing but a geometric statement. At the beginning of the sequence of the motion statement, the tool must be given a starting point. This is likely to be a target point, the location where the operator has positioned the tool and the start of the job. Now the part programmer key into the starting position with the following statement: from PTARG is nothing but from the target point. Now where from is an APT vocabulary word indicated, that is the initial point, PTRG is a symbol assigned to the starting point. Another way to make the statement is also a very simple one, from, and also it can be fixed by a coordinate systems which is nothing but x and as well as y. Point to point motion. There are only two commands, go to and as well as go DLTA, go delta. The go to statement instructs the tool to go to a particular point location specified in a descriptive data. For example, go to /p2, go to slash 25 comma 40 comma 0, which is nothing but xyz coordinates. The first command p2 is the destination of the tool point. In the second command, the tool has been instructed to go to the location where the xyz is defined. Go delta command specifies the incremental moves for the tool. To illustrate the following statements, instructs the tool to move from its present position by a distance of 50 mm from x direction, 120 mm from y direction and 40 mm from the z direction. Point to point motion. The go delta statement is useful in drilling the related machining operation. The tool can be directed to go to the given hole location. Then go delta command can be used to drill the hole as in the following sequence: go to /p2, go delta /0 comma 0 minus 50, go delta /0 comma 0 comma 50.